Hey guys, so today we're going to talk about natural logs. Now natural logs are similar to common logs, but it's just that they have a different base. They have the base e, unlike the base 10. So if I were to write this out, it's like I have the natural log with a base e of x equals y. So that's how natural logs look like. So let's go over some log properties for natural logs. So the natural log of e is 1. So it's kind of like if we had the log of 10, that would be 1. Okay, so then let's go through the other ones. So then we have natural log of xy. We can also write that as natural log of x plus the natural log of y. Another one that we can say, so moving on to 2, I'm sorry I went to 3. So 2, the natural log of 1 is 0. It's just like if we had log of 1, that is 0 as well. So then moving on to number 4, so natural log of x over y. So then we would have natural log of x minus natural log of y. And then our last property, so this is working with conversions. So it's like if we have this exponent, we're going to move it to the front, so then we have n natural log of x. So it's a lot like logs, but you know, there's only a couple things that are different, nothing too crazy. So we can do the same things we did for logs, like we had condensing. So I did some of this earlier. So let's condense this. So the first thing I'm going to do is I'm going to move the exponent. So I'm going to move my 5 as an exponent, and I'm going to move my 6 as an exponent. So now I have the natural log of x raised to the 5th plus natural log of y raised to the 6th. And then my next step is to be condensing this, because this plus sign means multiplying the innards of the natural logs. So this is going to be the natural log of x to the 5th over y to the 6th. So then same thing with expanding. So looking here, we have multiplication, and we know that multiplication means adding. So we have the natural log of x plus the natural log of y plus the natural log of z raised to the 6th. But we have this exponent, so we need to move it to the front. So now we have the natural log of x plus the natural log of y plus the 6th natural log of z. And they all mean the same thing, it's just a matter of condensing or expanding. And then the last easy thing that we can do with natural logs is converting it. So with our formula for common logs, it's log base a b to x equals y. So if we have this one, our base here is e. So we're going to make e big, and it's going to be raised to the y, and it's going to equal x. So it's the same idea for logs, it's just now that we have a base of e instead of 10. So now the last important thing that we need to talk about with natural logs is solving equations where we have to use natural log. So let's look at example number 1. So we have natural log of negative 2x equals natural log of 3x plus 10. Well, since they both have the same base and they're both natural log, we can just set the two sides equal to each other. So now we have negative 2x equals 3x plus 10. And then from here, we solve for x. So I'm going to add 2x to both sides. So I have 5x plus 10. Subtracting 10 from both sides, I have negative 10 equals 5x. And then I divide by 5, and I get negative 2 equals x. Right? Not too bad. Same thing with common log equations. It's just now we have natural logs. So now let's move on to example number 2. This one's a little bit different. So for this one, we have e raised to the 3r plus 4 equals 59. Well, with this one, just like with common logs, you want to isolate the exponential first. So we're going to subtract 4 from both sides. So now we have e raised to the 3r equals 55. And now we're going to convert. So now we're going to convert this exponential to logarithmic form using natural logs. The reason I'm using natural logs in this case is because we have e instead of a number. So when I convert, I now have natural log of e raised to the 3r equals natural log of 55. I'm sorry, and I misspoke. I meant to say not convert, but taking the natural log of both sides. So I took the natural log of both sides, and so now I'm going to use my rules to figure out what all this is. So if I have the natural log of e with an exponent, that means we can move our exponent to the front. So now I have 3r with the natural log of e equals natural log of 55. And if we look back to our rules, we know that the natural log of e is 1. So right here, natural log of e is 1. So we can replace that natural log of e with 1, and so now we just have 3r equals natural log of 55. So our last step is to solve for r and get r by itself. So I'm going to divide by 3 to both sides, and I get r equals natural log of 55 over 3. And we can plug this into a calculator and get an estimate. And our estimate is about 1.34. That's what r equals. Alright, so let's move on to our last example. So we have natural log of 3 plus natural log of 2x squared plus 4 equals natural log of 12. Well, if you notice, they all have natural log, and so that means we can just combine the innards and solve from there. So our innards are 3 plus 2x squared plus 4 equals 12. So now I'm going to solve for x. So I'm going to combine these terms. So I have 2x squared plus 7 equals 12. I'm going to subtract 7 from both sides. So I have 2x squared equals 5. And then I'm going to divide by 2. So then I have x squared equals 5 halves. And then the last step, I want to take the square root of both sides to get x by itself. So then x equals square root of 5 over 2. And when it comes to square roots, we know that it is plus or minus, but these are always more likely or not to be only positive. Now, it's always good to double check to make sure it's not two solutions, but more than likely, it's going to just be the positive solution. Alright, so that is it for natural logs. So have a great day and stay safe out there.